Assalamualaikum and good morning. Okay, today I would like to continue our lecture with the topic 5, which is corrosion. I hope that you have heard this word about corrosion, which is the degradation of material because of an environment. Okay, so before I proceed, I would like to definition of this corrosion. Okay, so what are the meaning of corrosion? In what we can define the corrosion as a destruction or degradation of metal by a chemical or electrochemical reaction with surrounding. So why most metals are degrade because of the environment and not other material like polymer or ceramic. Okay, so because of the electrochemical process or reaction, metal can change their chemical state, their chemical bonding because of the environment. Okay, so the electrochemical process which involve in reaction of metal, which relate with the electricity and the chemical reaction, meaning that the movement of atom or the movement of electrons. Because in metal bonding, the electron is free and can move, and therefore, because of the movement of electron, then the electricity will generate, and there will be also the chemical reaction involved in the metals. Okay. The corrosion occur in a gaseous environment, which we call it a dry corrosion, or in a wet, in a wet environment, we call it in a wet corrosion. So maybe because of the liquid surrounding, then the metal will have some corrosion. The term of corrosion is restricted because they will attach to metal only. And we can see in metal like iron and steel, the rusting, when we call it rust, so that is also part of corrosion. But some of non-metal and non-ferrous metal like aluminium, they will not corrode as fast as iron and steel. So we can see the rusting and the rust of iron and steel is a part of a corrosion process. This is the example of material that we can see in our daily life, which is made from steel, and this is the corrosion process. So the byproduct of corrosion is rust. You can see from the appearance. Corrosion, we have three parts, which is we call it aqueous corrosion, which involves water, and atmospheric corrosion with in air or water, and also salt, because something like seawater, because they have salt. And we also have high temperature corrosion. Normally occur at high temperature for the certain application like turbine. And this high temperature we have oxidation, which involve the oxygen from the environment, and also a hot corrosion, which sometimes occur with other gases. Okay, what are the importance of this corrosion? Because the corrosion will have a serious problem to the engineering. Actually, we can relate with the economic, because we have to replace some of the material, so they will have some impact to the economy, or the price of the product. Okay. And then the corrosion also will involve with the safety, because some of the design or the structure, if they have some corrosion problem, and they will involve with the safety because we need to replace the whole building, for example, because some of the part have a corrosion, and then if we are not replaced, they will affect to the people, to the surrounding. And also corrosion is will have some effect to the conservation of resource, which we can see the waste of the material. In addition to the cost of to replace, because that we call it a direct loss, corrosion also include the indirect loss. So what are the indirect loss that we can see? Loss of the production shutdown or the failure, because when we have some corrosion problem, some of the production we have to shut down, for example, like a turbine engine, right? So if one of the blade have certain corrosion problem, so we have to off the whole turbine itself, and the production for that kind of turbine will be slow, or will lost lah. We have to shut down, and the whole maybe because of the maintenance, then we have to stop the production. Okay, so not only that, for example, oil and gas industry, water, because of the corrosion of the piping, certain pipe will have some corrosion. We need to replace, and then we have to stop the whole system. Okay, and corrosion also will have relate with the efficiency lah. Meaning that the efficient of the system, the product will be lost. And also high maintenance, uh, we need to add another cost for the maintenance. And then loss of the product quality due to the contamination, because corrosion will have certain byproduct. So the byproduct of corrosion will have some contamination to the material. And lastly, high cost of fuel and energy as a result of leakage of corroded pipe. Okay, this is the example of a type of corrosion. We have general or uniform corrosion, and the other one we have localized corrosion. So for the general or uniform corrosion, we can see from this example, the byproduct of the corrosion have certain uh, uh, have a uniform on the whole of the material, the design. But for the localized corrosion, actually there are many forms of localized. It depends on the nature or depend on the material itself. Then we cannot see clearly the localized corrosion. Normally we can see the effect. For example, after certain crack or after we can detect the hole, and then we can see the part of component is already corroded. So we can see the example of here, which is galvanic, which is combination of two metal, then one of the metal will be corrode, and this is like a crevice. We have a hole here, but the hole we cannot see in our eye, and then because of the corrosion will attack to the internally, which is we cannot see because of the surface coating, for example. Then also pitting or stress corrosion, but the effect is the internal structure of the material. So that we call it a localized corrosion. Actually, metal have a tendency to corrode compared with other material like polymer or ceramic, because of metal have certain uh, corrosion product. So this production of this metal from their ore, from their raw materials, requires energy, which is heating and melting. And certain environment are also offer opportunity for this metal to recombine and revert to their low energy state. So that is the reaction of the metals. Then corrosion also we can describe as an extractive metallurgy in reverse, because we can extract all the process to the nature side of the metals. Okay, this is the example of the corrosion process. I hope during your secondary school in science, maybe you already done this simple experiment. If we want to study about corrosion, so we can relate with the chemical reaction. So we can have a certain experiment, a simple experiment. We take a piece of metal, whatever metal, but in this case we use a zinc because it's very common and quite easy to get. So we just cut a piece of zinc and then we have certain acid. For example, we take hydrochloric acid and then we just immerse the zinc plate to the hydrochloric acid. And we can see after several minutes or seconds, we have certain bubbles, which is the chemical reaction between zinc and the environment, which is aqueous solution hydrochloric acid. Okay. So how we can explain about this reaction? So we add hydrochloric to zinc and then we can get a zinc chloride, and this is the bubble, the gas that we can see, but the corrosion product is a zinc chloride. So this is part of the chemical reaction during the corrosion process by using aqueous solution. So we can divide into two process actually, which is the first process. We have to add another electron to the zinc. So this is an anodic or oxidation process. But the second process is the reduction from H. H is from the solution, from the water, hydrochloric acid, and then they will form a gas. So this process is a cathodic or reduction process. Okay, so this is the schematic diagram which we can see the process of corrosion when we immerse zinc plate to the hydrochloric acid. So we can see hydrogen and also ion from the hydrochloric acid, and this is a zinc a metal. So the anodic process, which is convert zinc to the zinc ion, and the cathodic process which change the hydrogen to a gas. So we can relate this process in general of the anodic and cathodic reaction, which is for the anodic reaction, which involve the metal dissolution or corrosion and the loss of electron. But a second process, we can see the addition of electron, which is the reaction. So normally in acid environment, we can see the hydrogen production because we can see the gas. But in natural or alkaline solution, we can see the presence of OH, the oxygen and hydrogen. So this is in general the cathodic reaction based on the environment. Okay. And when we refer to the metal itself, why the metal will dissolve by the second reaction, which is the metal will combine with other element to produce a byproduct of corrosion. So this is another example. Then we can see if we immerse the zinc in a copper sulfate solution, then we can see after several times the zinc plate, they have a duct which is deposit to a zinc plate. So the copper is a byproduct of corrosion, and they will deposit. But in this case, this is not dissolved, but they have certain deposition. Okay, so when we relate to the chemical reaction, when we refer to the copper sulfate solution, so now copper, they have certain byproduct, but zinc will dissolve, which is oxidation, but the copper is the reduction process. Okay, so therefore we can see copper deposited to the zinc plate. So the zinc plate are not dissolved. So this is the process that we can compare the corrosion process in between two different aqueous solution, two different environment, which is in acid, they will dissolve, the copper will dissolve, but in copper sulfate, in certain condition, the copper will not dissolve, but there are also corrosion product which is deposited to the zinc plate. Okay. And therefore, we can relate with the corrosion process, which is the corrosion process with effect on the environment. So we have to analyze what are the environment of this metal. So we know that whether it's dissolved or they have certain byproduct. Okay. And then in all cases, then we can see the process of anodic reaction, uh, which is from, for example, ferrum or aluminium. So this is the example of the reaction, which we can see the chemical process of the corrosion. In general or overall, when we have certain metal, we can see that M is a metal, any metal, for example, ferrum, aluminium. So we can have a certain general equation, but if we have some acid medium without oxygen, then we can see they have certain hydrogen gas. But in acid medium, they will form a oxygen, which is a dominant. Then we can see the byproduct is a water. But in a neutral and alkaline medium, they will produce a hydroxide. Okay, this is the process of corrosion, part of corrosion, when we can see steel, the most common material that we use, the corrosion process or the rusting that you can see from the steel material. This is part of or the example of corrosion process. What are the chemical reaction of the rusting process? So first we have to write the anodic process, which is ferrum changed to the ferrum ion. And cathodic reaction we can see from the oxygen from environment, because the steel, when we have certain in environment, they will the process from the environment, and then they will produce whether water or hydrogen gas. So overall process of the rusting, we can see the ferrum oxide will form, which is the byproduct of corrosion. We call it a rust. So this ferrum oxide will deposited to the steel. To the steel. So we can see from the surface, they have certain rusting or the ferrum oxide. So overall process, then we can see that the steel part combined with the water from the environment, they will produce a byproduct of steel, which is rusting. And that is the corrosion process of steel. Okay, then that is the example of the corrosion, and we can relate with the rusting. But now, how to protect the metal or steel from the corrosion? So there are certain method that we can protect our metal so that they will have a delay of the corrosion process. Eh? So normally we can use a sacrificial anode. So this is another anode material that we can use to protect the metal. So normally the sacrificial anode will corrode, but this sacrificial, therefore we call it sacrificial because they will sacrifice and they will corrode, then they will protect the steel. Okay, so another protection because we can use magnesium. For example, because magnesium is more active compared to other metal. So this magnesium will corrode and the pipe, the steel are not corrode. So in terms of the magnesium, because we can replace them, we can uh, get a new one compared to the structure steel, very difficult to replace. So the electron will go through the magnesium and then there will be a corrosion process for the magnesium. So that's why how we use a protection of the steel structure to replace with other metals. Okay. Okay, what are the requirements for the corrosion to occur? In order to corrosion occur, we need certain step, which is this is a form requirement for the corrosion to occur. The first is anode. The anode, which is the surface of a metal, which can easily corrode. And also we have another cathode, which also another type of metal, uh, which the process of the reduction will occur. And number 3 is electrolyte or the in contact, the in contact of the both metals. And number 4 is the electrical connection, which is the electron can flow. So when there is an electrical connection between anode and cathode, then there will be a flow of electrons. So they will generate an electrical. So this requirement will have a corrosion process to occur. Okay, I think that's all for the introduction of corrosion. I hope later we will go in detail about the corrosion. Okay, thank you.